All right, so for 3 notes, we have 2 different things that we have to do, solving for all values versus one lap. Well, what's the difference? Solving for all values, we would traditionally have our solution, but we want every single value that it possibly could be. So if we wanted to get back to that same spot, we could add 2 pi and we would get back to that same spot after completing a revolution around the circle. But how do we get back there over and over and over again? We input an integer. So what is k? K is an element of an integer. And that's what this says. It says k is an integer. And we will use this for pretty much every answer when it's asking for all solutions. So what does that say? I'm putting in an integer here so I can get back to that same spot over and over again. I could put in anything positive, I could put in anything negative, and that would go both ways and get back to the solution that we just talked about. What's the difference then with the one lap? This is something we've worked with before, and that was where theta was between 0 and 2 pi, including 0, not including 2 pi. So that's something we were working with before. What's new is in blue. Let's go to number 1. It says find all solutions. Well, if I'm finding all solutions, remember I want to make sure to add the 2 pi k. Other thing that might help you is I'm going to replace the sign with x and just solve for x. This becomes pretty simple, right? So then when is x negative 1? Well, I don't want x anymore. I want to know when sine of theta equals negative 1. And we've already done this part. We've talked about this 100 times. Here's sine being negative 1. What value is that? Well, the value would be 3 pi over 2 for the theta. But that would be a good answer if we just wanted one lap. We want all solutions, every solution possible. And that's where we employ the 2 pi k. Again, where k is an element of an integer. So this is our best answer. That's going to get us every single possibility for number 1. It's going to land us here. And then it'll land us here again if we go another revolution. And again and again and again. All right, let's try number 2. We're going to do that same thing. We're going to replace the trig function with x. We'll solve for x. And then we'll rewrite this as tangent of theta equals 1. Well, when does that happen? That happens with pi over 4 as our family. Also, for tangent to be positive, we need both of them to be positive, sine and cosine, and both of them to be negative. So first and third quadrant. First quadrant would be pi over 4, and I would add the 2 pi k. Oops, I forgot my pi. Then the third quadrant would be 5 pi over 4. Again, where k is an element of integers. So this is a great answer. This will get you full credit. Some people like to be a little bit more efficient, and in terms of tangents, this is like a little special case because, remember, tangent repeats in half the time of sine and cosine. So another great answer would be saying that I could just take pi over 4 and add pi k to it. Why is this a good answer or a more efficient way? Because this is the only one that you have to write. So think about it. If I'm in the first quadrant here, that's pi over 4. This one's 5 pi over 4. They are pi away from each other. And that's why that's a reduced or simplified way of writing it. All right, let's move on to number 3. We've done something similar to number 3. We're going to do a couple things all at once. Remember back in trig identities, we broke this fraction down. 2 over 2 is 1 minus square root of 2 over 2 equals 1 plus x. And I replaced cosine with x. So I'm going to get x by itself, and I'm going to subtract 1. So I have negative square root of 2 over 2 equals x. So I want to know, when is cosine of theta equal to negative square root of 2 over 2? So think family, that's got to be pi over 4. And think quadrants. Quadrants would be quadrant 2 and quadrant 3 for cosine being negative. So I'm going to write my two answers. Theta in the second quadrant is 3 pi over 4, again, plus 2 pi k. And theta in the third quadrant is 5 pi over 4, and that's plus 2 pi k as well. Again, here's our answer. Remember, k is an element of an integer. All right, let's keep going. This one would be 2 equals 1 plus x, right? I would move the 1 over, x equals 1. Kind of looks like our same answer from number 2, right? So when is tangent equal to 1? And we can write one of two answers. Keep in mind, this is pi over 4 family, and we want first and third because the cosine and sine are both positive here, and these are both negative in this quadrant. So when I divide a positive by a positive, I get a positive, and a negative divided by a negative is also a positive. So I'm just going to write my shorthand, pi over 4 plus pi k, where k is an element of an integer. And that can be our final answer. Now, the other one that you might be able to do is up there and figuring out this would be the same answer here as well. So either one of those would work. All right, try number 5 and 6 and check your answers. All right, check those two out, see if those make sense. We're going to go to number 7 and 8 because they're a little bit different. The reason why they're a little bit different is because now we have a number in front of theta, which we haven't had before. So how is that going to affect us? Well, when we have a sine graph, we usually work with 2 pi. When we were back up here, we were adding 2 pi. Well, that's going to affect it by, because that's our b value, in two different ways. Our angle measure and then how we write our answer. So this comes out to be pi over 2. So when we do this one, we're going to be adding pi over 2k to it. Again, because that's affecting the period if we were to, let's say, graph. So keep in mind, we're still going to do our solving. If you want to put x in here, you can. We'll worry about that for theta in a little bit. So when I do this, I got to divide by -6. I get 1/2 equals x, but that was really 1/2 equals the sine of 4 theta. So I want you to just think about when is sine 1/2, that's pi over 6's in the first and second quadrant, because sine is positive there. But when we write our answer out, we're writing 4 theta instead, equals pi over 6, and 4 theta equals 5 pi over 6. So in terms of solving this, right, I'm going to multiply by 1/4, multiply by 1/4. So theta equals pi over, right, we're multiplying by 1/4, pi over 24. And same thing goes for this one. I would be multiplying by 1/4. So theta equals 5 pi over 24. And remember, we're going to add to that pi over 2k. So I have one of my angles and another one of my angles. Keep in mind that we have k is an element of integers. So those are our two values there. All right, so on this one, we are looking at the 2 in front of theta. So we have to do our 2 pi divided by 2, and that's going to tell us that we add pi k to everything. So we're trying to solve this again. Remember, this is going to be x equals -11 pi over 2. So I got to add 5, which gives me a negative 1/2. So now I want the cosine of 2 theta to equal negative 1/2. When does that happen? Oh, that's pi over 3's. And what quadrant? That would be the second quadrant and the third quadrant. So if I list my second quadrant pi over 3, and I list my third quadrant pi over 3, I also need to remember that this equals 2 theta. This equals 2 theta, so I can solve for theta. So when I do this, I'm multiplying by 1/2. So that gives me pi over 3 as one of them. And then again, I'm going to multiply by 1/2. That gives me 2 pi over 3. So these are the two angle measures that I'm going to use. So here's my final answer on this one. Pi over 3 plus pi k, and 2 pi over 3 plus pi k. Again, k is an element of an integer. So there's my final answer, taking into consideration the period, or the phase period shift. There we go. Get it together. All right, we got a couple more to go. I don't know what just happened, but we'll keep going. Isn't that so special? All right. So now we're going to go back to solving between 0 and 2 pi. A couple things here is you may have to factor, and you're only going to write answers that fit within those parameters. So if I look at number 9, I'm going to do some replacing, and I'm going to replace the cotangent with x. You notice you have x squared. We want to get that factored, and we want to get everything to one side, set equal to 0. So I'm actually going to move everything to the left. So I have x squared minus 2x plus 1 equals 0. Again, what did I do there? I added x squared, I subtracted 2, and I subtracted 2x. So now try to factor this. We can factor this into x minus 1 and x minus 1 equals 0. And then remember, I'm not having x minus 1. I have cotangent of theta minus 1 equals 0. Well, we know how to move the 1 over. That would be cotangent of theta. Cotangent of theta equals 1. When does that happen? Pi over 4's and first and third quadrant, because that'll give us a positive angle measure. So pi over 4 in the first quadrant is pi over 4, and in the third quadrant that would be 5 pi over 4. So theta equals those guys. Normally you'll see these written as pi over 4 and 5 pi over 4 in those curly brackets. That's probably how I will start writing it. Okay, let's try the next one. Number 10. I have a lot of stuff going on in here. So on this one, I am going to do a little bit of replacing. The first thing that I notice is if I move this to secant so I can set it equal, I'm going to add 2 secant. So now I've just made my problem a little bit easier, and that's by getting rid of that term. So if you're putting x and y in here, so maybe you do negative xy plus square root of 2x. What do they have in common? So maybe you factor out what they have in common. So a negative x, and then you'll have y minus the square root of 2 equals 0. And then I'm going to go back, because I don't love the two different trig functions having two different variables. I'm going to rewrite negative x as negative cosine of theta equals 0, because I'm setting this equal to 0 and this equal to 0. So then in place of y, I'm going to put secant of theta equals square root of 2, because I can move that over by adding square root of 2. I can also divide out that negative, which really won't matter. Cosine of theta equals 0 still, and this one's ready to go as well. So in terms of the two different answers here,